because of my bandwidth restrictions today. So this is Dr. Karthik again. I'm extremely sorry for the inconvenience yesterday. And let's get started without wasting any much time. So today, let me talk something about Python programming. Also, I'll touch upon optical character recognition application as well, right? So these are the two things that I'll be touching upon. I'll use Python programming and help you to understand how you can use that in order to achieve this task of optical character recognition. Okay, so these are two things that we'll be focusing on. Also, I'll tell few other things on some of the latest things that are happening, so that you'll get a perspective about some of the latest technology. Okay, so coming to the human visual system, so if you see here, so where is the camera coming from, right? Where is the motivation for developing a camera, right? So building a camera is an attempt was made in order to recreate the human visual system, right? So that was the main idea behind trying to starting building a camera as such, right? And now here, if you see this human visual system, it has two main components. Yes, of course, there are several other things, but it has two main components. One is cone, and the other is rods. Okay, and now cone, what does it do? Cone tries to help you to recognize the intensity information, whereas the rods help you to recognize the color information. Okay, so here if you see, there are three kinds of rods: red, green, and blue, if you can see that. Okay, and whereas the red color rod is trying to detect only the red color wavelength from the light that is coming into the eyes, human eyes, whereas the blue color rod is trying to detect only the blue color wavelength, and the green color rod is trying to detect the green color wavelength. Okay, so now how do you think the rest other colors are going to get generated over here is, you have, so these the rest other colors will be the combination of these three colors: red, green, and blue. Okay, so that's how your color information will be perceived by your human visual system. Okay, and now we'll also do a small experiment in relation to this. Okay, so I'll show you a small experiment related to Fourier transform, and we'll try to pitch in this. But yeah, so this is about the human visual system. Okay, but now let's go how the camera operates. So it's same. It's a human visual system. The way your image is being perceived, that the same motivation is carried forward to your image formation in the camera as such. Okay, so where you have an illumination source, and the light is coming onto the scene element, and the light is getting reflected back onto your imaging system, and the image is getting formed on these sensors now. Okay, so now the output is a digitized image as such. The input is an analog signal that is coming in, and the output is a digitized image. Okay, and if you see here, every sensor tries to capture an information over here based on the amount of light intensity that it receives. Okay, so if a sensor is recording say 112 value at a particular location, okay, that means it has received, and the number of photons that were received were proportional to were responsible for creating that 112 value. Okay, and suppose, say, I'll show you here, right? So what is an image? Image is nothing but a matrix of values. Okay, and now here so a matrix of values arranged in a certain format is what will help you to get an image. Okay, and so you have two kinds of images: grayscale image as well as the color image. Okay, and now if you see here, there are several different matrix of values that are there: 105, 112. So that itself will indicate the amount of the light that has been reaching the camera system altogether. Okay, and Suresh Garu, is my voice and the
Yes,
screen share is perfect?
Yes, sir. Yes, sir. Perfect, sir.
Okay, thank you. Yeah. So I have these matrix of values now in the grayscale image. So a lot of people call this grayscale image as a black and white also. So however, the reason it's called as grayscale is every intensity value ranges between 0 and 255. Okay, that's the reason why it's called. That's a different shades of gray will come into your grayscale image. That's the reason why it's called as a grayscale image. Okay, so grayscale image is represented as a 2D matrix. It has a set of rows and columns. Okay, it is represented as a 2D matrix inside a computer. Okay, where is the 2D matrix is coming from? The 2D matrix is coming from here. Okay, you see here, it's the matrix of sensors which are there, and each and every sensor is recording certain amount of information about the scene element, and that's the reason why it has some kind of an that's the reason why you will represent a grayscale image with an 2D matrix. Okay, but now grayscale image is all about intensities. Okay, but human visual system is so powerful, it visualizes a color images as well. It tries to infer the color information about the objects or the surroundings it's seeing currently. Okay, because you don't just see an intensity right in front of you right now. There are several different objects, and every object has a color. Okay, so now how do you represent the color? Okay, uh, color images. The color images are represented by three different matrices stacked together. Okay, and when you are considering the three-dimensional matrix, okay, in computer programming we call it as a 3D array. Okay, it has rows, columns, and the third dimension also it has. Okay, and the third dimension actually here it represents the channels. Okay, when I mean by channels, the first channel will be corresponding to the red, and the second channel corresponding to the blue. Okay, most of your image displays actually considers that in the three-dimensional matrix, they will assume that the first channel is corresponding to red, and the second channel is corresponding to green, and the third channel is corresponding to blue. Okay, and the rest other colors in the image actually are getting generated because of the combination of these three different components together, and that's combination of these three components together is what is generating the color image as such. Okay, so now this is how you will represent the color image. Color image is always represented as three-dimensional matrix. Okay, so let me show you something with related to programming. Okay, so that you will get an idea. Okay, I'm just opening. So I'm trying to open this something called Google Colab. Okay, uh, some of you must be aware of it, some of you might not be aware of it. Okay, Google Colab is a kind of environment provided by Google. Okay, where you can do your Python programming, and it offers you a GPU capability also, but of course for a limited duration of time. With the free version, it's only for a limited duration of time. Okay, and suppose say here in the screen, uh, in the screen, if you see I have an NVIDIA. I use this command called right. I use this command called NVIDIA -SMI. Okay, so when I execute that command, okay, what I'll get is I'll get this information about the GPU that has been assigned to me currently. Okay, the GPU that has been assigned to me is what I'll be getting the information about it. Okay, if you see here, I'm getting almost like right, almost a 11 GB GPU RAM, and I'm getting allocated. Okay, if you want to invest by yourself this much RAM, this much this kind of a GPU actually costs you few lakhs of rupees. Okay, you cannot simply buy it. Such a kind of valuable resources you are getting at a free of cost within this Google Colab environment. Okay, and GPU is extremely useful in executing some of your artificial intelligence related applications. Okay, and because especially with the images and the videos, you need to do parallel processing, and for doing parallel processing, GPU is the best. Okay, so so this is a GPU that has been allocated to me, and what you need to do is immediately you also, one very important thing here is you need to use this command. I'll share this notebook anyways with all of you. Okay, so that you will get an idea. And what you need to do is you need to execute this command, whatever is there over here. Okay, so this command you have to execute it. Okay, so that you can mount your Google Drive. Okay, see here, whatever we are doing with respect to image processing or anything related to data science or machine learning, what you need to do is you need to load the data first. Okay, and for loading the data you have to store it somewhere, right? And the so what is the place within this Colab environment? uh, so it will also give you some virtual space. Okay, but that virtual space will get expired after the session get expires. Okay, it will go away. So whatever data that you might have stored and during the course of program execution and everything, the results you might have saved and everything, it will go away. So what is the solution now? You need to use this command which I'm showing you, which I'm highlighting you today here. Okay, in order to mount your Google Drive into your Colab environment first. Okay, when I mean by mounting, you will give the permission, to for the Colab to access your Google Drive, because Colab is a different application for Google, as well as a Google Drive is a different application for Google, and you're trying to bridge between these two things first. Okay, and for which you're trying to use Google this command in order to do that. Okay, and so what I'm trying to do here is, just a second, yeah, what I'm trying to do here is I am changing my drive. Okay, on my Google Drive, I have my contents in this folder called select smart demo. Okay, I'm changing my directory. If you have used any Linux based systems, or for that sake any Windows based systems also, if you have an experience in working on a command prompt, okay, cd is the command used for changing directory. And you just use this cd command, and I've changed my directory, because I'm once I have mounted my Google Drive, it will be on top of my home folder in the Google Drive, and I have saved all my data and all my images in the select smart underscore demo. Okay, so that I'm changing my directory there. Okay, so now here, if you see, here is the command which I have used this, and import OpenCV2. Okay, for all the beginners who are into image processing or computer vision for the first time, or Python programming for the first time, import is nothing but something like #include stdio.h in C programming. Okay, and so if I can ask you, what does #include stdio.h do? Maybe I would like to see your answers on the chat box. What does #include stdio.h do? It's a header file, correct? Okay. What does it do when you're, yeah, you're importing, typically you're importing the predefined functions basically. Okay. Right. And you're all that are related to input output, standard input output, right? So you are trying to import those functionalities within your program, and so that you can use them and do some few things with them, right? And now for that sake, what we'll do is in Python, the analogous statement for it is import CV2. Okay, what is CV2? CV2 is a collection of OpenCV libraries. It's an OpenCV package as such. Okay, now I have something called matplotlib also. Okay, matplotlib is another package which will offer you several functionalities with respect to plotting the images or plotting the values. If you want to plot any graphs, they have some very efficient functions within it, and you can use them. Okay, so I'm importing both these two things. Okay, and by means of im read, what I'm trying to do here is I'm reading my image within the, when I'm mentioning the parameter 0, I'm reading the image in the grayscale format. Okay, so I have a cameraman image. So this is how the cameraman image would be. Just a second. Right, this is how the cameraman image would be. Okay, and right, so here if you see, I am printing the img value. Okay. If you can see, when I'm printing the img, it is what does img contain? It's a matrix of values again. Okay, it's a matrix of values. It's a two-dimensional matrix. It has certain number of rows and certain number of columns, and that is how you will represent a grayscale image. Okay, with a single two-dimensional matrix. Okay, and if you see here, plt.im show, actually it's trying to display the image onto my screen. Okay, I am mentioning that CMap color map as gray. Else, what it does is PLT, the PyPlot package in Matplotlib assigns some kind of a pseudo color. Okay, and uh, so what, and then some of you might have a doubt that, okay, OpenCV also have an IAMShow function. Uh, but if OpenCV has an IAMShow function, then why have to include matplotlib.pyplot package as well? Why do you have to do that? Okay, that's another big question that people will have, right? Because OpenCV's IAMShow function, it has some kind of an incompatibility with the Jupyter notebooks in Colab. Okay, and it will not execute properly. The Jupyter notebook will get crashed, and that's the reason what we are trying to do is, for just for displaying the image, we are using this pyplot function, pyplot capability in the matplotlib package. Okay, so now if I want to read the color image, okay, what is the basic difference? I am reading the color image, but I'm not passing the parameter 0 now. Okay, here I am I'm passing the parameter 0. For reading the color image, I'm not passing any kind of a parameter now over here. Okay, if I display that plt.imshow of img, okay, I'm displaying my image, okay, of mandrill, and this is a famous image for image processing people. If you have worked earlier in this area, then you must be very well aware of this image. Okay, and when I'm displaying that image, okay, and the shape of the image, if you see here, it is 288 cross 288 cross 3. Okay, okay, here if you see here, right, you see here, it's a 288 cross 288 cross 3. Okay, and so the first channel actually should indicate, ideally, in the ideal case, majority of the display systems assume the first channel to be red and the second channel to be green and the third channel to be blue. Okay, but the problem with OpenCV IM read functions is, so whatever IMG is getting returned, okay, the way OpenCV reads is, the first channel it interprets as blue, and the second channel it interprets as green, and the third channel it interprets as red. Okay, so you have to do appropriate color conversions in order to display the true color. Okay, so what we try to do is, I am using CBT color and trying to pass on the parameter of color underscore BGR to RGB, and I'm doing that first, and then I am transforming the color so that my matplotlib IAMShow, whatever it is, okay, it will try to display the proper color image. Okay, but here if you see, if I don't use matplotlib IAMShow, okay, but I'm using CV2's IAMShow, okay, then I will not have any problem. Since I'm using a different package altogether in order to display my image, I should try to understand all the details of that package first before even further experimenting on it. Okay, so this is about the color transformations as such. Okay, so let me get back to my PPT. Okay, so that right, good. So so this is of the grayscale image, color image, right? And so these are some of the useful Python packages for image processing and computer vision. If you see, the first one is OpenCV, NumPy, scikit-image, scikit-learn, Matplotlib, TensorFlow, Python image library. So these are some of the useful Python packages for performing some of your image processing or computer vision tasks. Okay, and so let's get back to this block diagram, right? As day before yesterday, I was talking about this block diagram. The first one being the data capture, the second one being the pre-processing, the third one is feature extraction, the fourth one is region of interest, and the fifth one is the scene inference. Okay, so when I'm talking about this block diagram, and then I've also told you that in what way this block diagram is going to be useful for you is, given any image processing or computer vision tasks. Okay, so how would you actually go about it? Is there any standard framework for you to perform that task? Okay, so this is a standard framework. Any computer vision or image processing task, actually you can divide it into multiple subtasks. Okay, and each of the subtasks actually can be part of this these blocks, or multiple subtasks sometimes can also be part of these blocks. Suppose say your image processing system needs the help of performing the denoising as well as dehazing, both of them together, or deblurring together. Okay, and in that case, both denoising as well as deblurring comes under pre-processing only. It cannot go into feature extraction. Okay, so that is what it is. Okay, so any image processing or computer vision task you can further subdivide into several subtasks, and then which can help you to and each of the subtasks are being assigned now to each of these individual blocks, and then that's how you'll be able to do the job. Okay, so now let's get to the optical character recognition as such, right? So what is optical character recognition? Now, what did I say? My image is nothing but a matrix of values. Okay, so my software program sees my image as a matrix of values, just matrix of values. Okay, and suppose that you're designing an image processing system in order to design some kind of a text in it. And let's take an example of a license plate recognition system. And your license plate recognition system is about recognizing the text on the license plates, right? So if you have to do that, okay, then so how will you process this matrix of values in order to infer that text from it? Okay, so that is what is the optical character recognition technology is all about. Okay, and it's extremely useful for automated text entry into the computer science systems. And there exist several challenges in digitizing these documents. Okay, some of the applications of OCR, if you see, the first one being the license plate readers, digitizing invoices, digitizing menus, digitizing ID cards. So these are some of the interesting applications of OCR. Okay, and now there are several different challenges right now. Okay, you will not get your document so clean. If you want to digitize it, then there'll be several different challenges in it. Something like blackhands. If you see those columns, the one row over here. Okay, so this particular portion, if you see, there's a lot of noise in that header files. The word warning is surrounded by a lot of noise, and the boxed warning actually is surrounded by several noise, and the comments is also surrounded by a lot of noise over here. Okay, so there's a lot of noise here, right? That's we call it as a blackhands. Okay, and if you see this document, actually this document is related to what do you say? This document is actually is showing a low resolution document. Okay, so what are the typical ways of digitizing a document? As the first step, that if you take the data capture step, you can either use the flatbed scanner, okay, or you can use some form of an mobile phone camera also in order to capture the document images. Okay, if your images are of low resolution, your text processing softwares will fail in doing its job. Okay, I'll show you some portion of code. You will be able to understand why I'm saying this. Okay, so pre-processing plays a very important role, because your text processing softwares assume that the input image that is fed to them actually is clean of distortions. It is of completely clean. Okay, so this is a low resolution document. And the third one is the perspective distortion is there, right? So if you see, there's a perspective distortion, and then you have a lot of some kind of a slantiness is there. Okay, but my text processing software is not trained to detect this perspective distorted images. So before giving it to my text processing software, what I need to do is, I should correct for this perspective distortions first. Then only I'll be able to give it to the text processing software. Okay, and these are the three challenges, and these are some more challenges. If you see here, this is some kind of a rotated text. The text itself is completely rotated. Okay, and you have to correct for this before even doing something about it. You have to correct for it. Okay, and this is a skewed text. Okay, the text itself is has a lot of skew. Why it is happening? Because this kind of a text was placed inside the water, and my camera is there outside the water. I've shown this video some time back, right? So this is a kind of a skewed text that I'm talking about over here. Okay, and now here, if you see, there's a watermark. Watermarks are there, and some of you must have worked on removing the watermark. And what is a watermark in this image is a draft, the word draft. Okay. And if the watermarks are also there, the text processing software will not perform fine. Okay. So you have to remove these distortions first in order to help your text processing software in order to do its job. Okay. So steps in OCR, you have to pre-process the image as I was emphasizing on. And today we'll look about pre-processing two different kinds of images. Okay. And the two different kinds of distortions, so that you'll be able to remove those distortions first, and then you can feed it to the text processing software. Okay. And you have to localize the text. When I mean by text localization, you have to understand where the text is. Okay. Here, these are the document images. Okay. This document images has only text. They don't have any kind of an objects present in it. Suppose say you are trying to detect the license plate number. Okay. And then you have a car, and then you have people around the car, people sitting in the car. There are multiple things that are there in your images. Okay. And in that case, you have to understand from all those contents, whatever are there on those images, and you have to identify only those regions which has text, that is my license plate information. Okay. And now that is what I mean by text localization. I have to understand, okay, individual characters I have to understand, right? Okay. So I have to able to draw, or I able to identify individual characters, and then only once I read the individual characters, those characters together form a word, and words together form a sentence. Okay, sentence together form a paragraph, and that's how I will be able to understand the document. So the fundamental step here is to understand where the characters are. Okay, individual characters you should be able to identify, and then you'll be able to classify that. Okay, this character belongs to C, this character belongs to D, this character belongs to E. Okay, that is what is a character recognition. Okay, so once you have recognized the individual characters, now it's up to you. So whether you want to identify words, whether you want to identify the sentence, or you want to write a summary of a sentence. Okay, that those all things you should be able to do in the pre-processing. Okay, these are the fundamental steps in optical character recognition approach. Okay, so what is the text processing software that we are going to use today for a demo is Tesseract is the software that we are going to use, and the Python wrapper for Tesseract OCR is a PyTesseract. Okay, and we'll be installing these packages on Colab, and that's how we'll see it. Okay, so let's go back to my session. Okay, right? How I'll be installing the Tesseract packages in Colab. Okay, so apt install is a way you will be doing in Ubuntu. Okay, and of course, if you have a Fedora kind of an Linux systems, what you will typically doing is you will use something called yum install, and that is how you'll be installing it. But this Colab environment is supported, backed up by Ubuntu. And that's the reason I'm using apt install tesseract OCR is a command that I have to install. Okay. And whenever I'm using a command rather than a Python code, okay, this exclamatory mark should be there. Okay. Then only it indicates to the cell, it indicates to the Colab saying that, okay, this particular command belongs to this is the command to be executed, but not the Python code. Else it will assume it as a Python code and it will throw errors. Okay, and I'm executing two things over here, and that's the reason I have successfully executed. When I press this, okay, this button, whichever is there over here, okay, if I press this, it will get installed. Okay, the play button. Okay, I will send this Colab notebooks, so I request you to practice so that you will get a better perspective. Okay, Suresh Garu, is everything fine? Can you just confirm?
Yeah, fine, sir. Fine, sir.
Okay, good.
Fine.
Thank you.
Okay.
Right. So now let's read up a text image first. Okay, these are the multiple packages if you see. Okay, import PyTesseract. Right. Okay, just a second. All right. Okay, so these are the multiple packages that you should think of. Okay, let me not zoom in. And PyTesseract, shuttle, OS, random. So these are the multiple things I'm trying to import. Okay, what I'm trying to do here is box plot. Okay, and Right. So let me ask you a few questions. I here at this point of time, right? So many of us must have done C programming, right? So when I am so, uh, uh, what is the difference between pass by value and pass by reference? Okay, what is the difference between pass by value and pass by reference? Maybe you can type your answer on the chat box so that I can take a look at it. What is the difference between pass by value and pass by reference? Right. Perfect. Changes reflect in the memory of pass by reference. Yes, perfectly correct. Okay. And how will you in C language or C++? What is a uh, way that you can achieve by? How will you get pass by reference mechanism? What is that you need to use in order to have the pass by reference approach? Just by passing a variable, will it happen, or you need to do something else? Yeah, and you're passing the address rather than a simple variable value. You're passing an address, and that's how you'll be able to get the pass by reference as such. Okay, the Python also, it's a pass by reference kind of an approach over here. Okay, and that's the reason what happens here is, okay, what happens over here is, and I'm reading an image, text image. Okay, and I'm sorry guys. Yeah. Okay, I'm reading an text image over here. Okay, and what I'm trying to do here is I'm writing a box plot function. Okay, and when I'm passing the img variable into the box plot function, okay, and I have something called im underscore copy is equal to img dot copy. What effectively I'm trying to do here is, so whatever the changes, even by mistake, if I am doing some kind of a changes onto img variable, okay, so it will not be getting reflected back outside the function. Okay, so it happens a pass by value. So what we need to do here is img has, will have a function called this object will have a function called copy. Okay, what essentially tries to create another copy. And now even if I do any kind of a modifications on im underscore copy, it will not uh, it will not it will not be getting reflected back into img variable. Okay, and in the simplest terms, I'm not come from a computer science background, so this is the way an electronics guy would explain you about the pass by value and the pass by reference. Okay, so I try to understand in a very I didn't keep the things in a very technical manner, but this is what is meant by pass by value and pass by reference. And Python operates in a pass by reference manner, and I have to use the copy, the best practice, even if you are not modifying the input value anyway. Okay, so what we would recommend you to do is that you use this copy function in order to execute it. Okay, right. And now what I'm trying to do here is, I'm in pytesseract. Pytesseract is which is a Python wrapper for tesseract library. What we do is, there's something called image to data function in it. Okay, what it's trying to do here is, image to data is extracting the data information within my image, the text data information within my image. Okay, and it is returning in the form of a dictionary D. Okay, there is something called a dictionary. The way you have arrays in C programming, okay, you have you have another kind of a data structure in Python called a dictionary. Okay, and a dictionary is like you can access the individual elements of a dictionary by using something called key value pairs. Okay, it will be associated as a key value pairs. And in arrays, how will you do it? In arrays, actually you're trying to uh, uh, access the individual locations of the array by a numerical number. Okay, and but here it need not be a numerical number as such. Okay, it can be a numerical number, it need not be a numerical number also. Okay, and that is the advantage. That's a more additional functionality that that it is giving you. The dictionary data structure is giving you more additional functionalities over there. Okay, so what I'm trying to do here is I'm getting the length of D of text. Okay, so text, what is the text comprises of? Text comprises of individual words. Okay, and what it is trying to do here is this dictionary D has all the information about the individual text which is there in my image. Okay, individual text which is there in my image. Okay, and what I'm trying to do here is I am trying to draw a bounding box around each text. Okay, when I mean by bounding box, so this is what is the bounding box. Okay, so this is what is the bounding box. Okay, I am trying to draw a box with certain color coding and everything around each word. Okay, so if you see, there are few words which are detected properly, and the few words are overlapping way they are getting detected over here. Okay, so now so because this is a first step, before even identifying what are the words presented, I should be able to clearly distinguish between word to word. Okay, then only I'll be able to understand each and every word. All right, so the dictionary D has also the information about so what are the coordinates of these words, where these words are. Okay, it will be present in the form of x. What is the x coordinate, what is the y coordinate, and how much is the width and how much is the height. Based on this information, you will draw the bounding boxes around each word by using this what do you say, CV2 dot rectangle. Okay, CV2 dot rectangle will help you to draw the rectangular bounding box around your around each word, and that coordinate information is present in that dictionary D, and that is what is being done in the previous step first. Okay, so once I have drawn the bounding boxes, what I'm trying to do is I'm returning that particular image matrix back to my original position where I have called my function. Okay, and what I'm trying to do here is I am using IM show again in order to display it, and that is how it's getting displayed like this. Okay, so I'm also using some other function called image to string, and for which I have something called extracted text, and if I have simply that extracted text, it will simply print as a string. It will count the number of empty spaces and everything it will consider. It will just read the text and it will print for you. These are the two important what do you say, these are the two important functions which you can make use of for this current demo. Okay, and the best part of Colab is in case if you have never used Python, and so the best part of Colab is that you need not install any packages. Majority of the packages are already installed, and you need not install anything from scratch. Okay, but of course, if you want to learn, what I would recommend is not to use Colab. Please use some Python IDEs like PyCharm or Anaconda, these kind of an IDEs in order to execute your Python programs. Okay, where you will start understanding about how to install packages and everything. But if you're not bothered about it, then Colab is the best place where all the packages, dependencies, everything is installed and it's there available for you. Only thing you need to do is you need to start writing some interesting programs related to your project. Okay, so this is what is the session. So this is what is a text recognition, right? Now what I'm trying to do here is I'm using an function called sp underscore noise. So what is sp is salt and pepper noise. What I'm trying to add over here. So what is that through salt and pepper noise? What I'm trying to do here is I'm generating a threshold by using a random number. Okay, and now if ever my pixel value is less than that particular threshold, I'm keeping it as 0. And if ever my pixel value is greater than threshold, I'm keeping it as 255. Okay, so what is salt and pepper? How does salt look? It's white in color. How does pepper look? It's a black in color. And if you're trying to mix both of them, okay, if you're trying to mix salt as well as pepper, okay, and then what you try to do, and you spread it across on any surface, and how it will look like a white and the black spots. Okay, white and the black spots, and that's how your salt and pepper noise will also look. Here the background is white, you will not be able to recognize it, but this is how the noisy image will look like. Okay, what is the first step? The first step here also is to recognize the use an IMRead function, okay, in order to read the image, and sp_noise in order to add the noise to the image, and then once I have get back the output from that function, okay, what I'm trying to do is I'm saving that image, okay. So where do you think all these images will be saved? It will be saved into your Google Drive if you have mounted your Google Drive onto this Colab environment, okay. So this is what it is. Okay, I'm sorry. All right, good. So once I've added noise, so what I'm trying to do here is I'm using the same box plot function which I've defined earlier onto this noisy image now, okay. So what's happening? The box plot is going out for a toss. It's not performing well. It's not able to recognize the individual words properly the way it has recognized here, okay, because of the noise which is there. Because your text processing software, PyTesseract or the Tesseract OCR packages generally expect your expect your images to be clean and neat, okay. So now what I'm trying to do, I'm trying to denoise the image now, okay. I'm trying to denoise the image by using this function called median blur, okay. So median blur, maybe we need a completely different session for me to explain about filters and everything, but median blur is a functionality which is there in OpenCV for you to understand about how to remove the noise, okay. You have read the image sp_noise and you have removed the noise, and then you use plt.imshow of denoised in order to remove it, okay. So how the denoised image looks like, this is how once you have passed a denoised image into the string function, the PyTesseract library, it's individually, it's able to detect the words perfectly fine, okay. It doesn't have any, it does not have any kind of a difficulty as such. It's exactly the same way, even though the characters are slightly distorted, okay. It's exactly the same way the bounding boxes are recognized, okay. The only difficulty here is because the characters are going out for a toss, image to string function will be showing an error, okay. But let's see what is the text which is there over here is, this is the second line of the same text, okay. But let's see, do we have the same kind of a text over here for the denoised image, okay. It goes for an error, okay. Instead of line, it prints as time, okay, because there is some kind of an while performing the denoising, your denoising algorithm has not done a great job for that particular character, okay, character T, and instead of L, it started appearing as T for the text processing software. So there's a lot of scope here. You can build a better denoising algorithms in order to denoise these images so that your text processing softwares like PyTesseract or Tesseract OCR will have an what do you say, will have that ability to infer the text out of these images, okay. Now let's look at the watermark. So this is about noise. Now having noise in the images will not aid the text processing softwares. Now here I have something like watermarks now, okay. I have something like OpenCV2, NumPy as NumPy, okay. NumPy is another array processing software, array processing package inside the Python, and all the very efficient array processing packages are there in NumPy, okay. And what I'm trying to do here is I have a watermark image inside my what do you say, in my Google Drive. I'm just reading it, okay. And once I have read it, I have sent it to my PyTesseract library, okay. And if I send it to my PyTesseract library, it goes for a toss down. If you see here, all the numbers are jumbled over here, okay. This is how my watermarked image is there. But when I'm trying to write a small logic in order to remove the watermarks from the image, okay, and give it to my text processing software, it will give me a structured output. It will remove my watermark and it will give me a structured output. Now from these words I can infer something about it. This inference, whatever you are seeing over here, this is much better when compared to this inference, okay. If you see here, there are a lot of errors, okay. See here, there's a lot of errors over here, okay. It's not able to detect the words properly, okay. So this is about explaining you the importance of a pre-processing algorithms, okay. And whether it can be noise, whether it can be other things. It's very important that you have to remove them first before even feeding it to your text processing softwares. Okay, and and you should be able to remove all these challenges in order to before even feeding it to the text processing software. Okay, and good. So this is uh, and many a times I hear so this is about the demo of Python. Okay, and let's see if we can get back about another demo. We'll look at see if that opens. I've just opened it. Okay, so before it opens, maybe I would like to hear from the participants if you are aware of a Fourier transform. When you are Fourier transforming an image or a signal, okay, which is more important, whether the magnitude is more important or the phase is more important for in a Fourier transform. I would like to hear on the chat box. Maybe you can type your answers on the chat box. Okay, somebody has said as both phase. Okay, Giridhar sir, you have attended multiple sessions. I think you should not answer. Right. Okay. Somebody is saying magnitude, magnitude. Any more answers? Both. Okay. Any more answers? So people who have typed as magnitude, can you tell me why? Why do you think magnitude is important? Somebody says as phase. Okay, ma'am. Can you tell me why phase is important? I'm not sure if you are there in my previous sessions. Phase. Okay, let us do because a phase actually is more important than magnitude, and because phase carries more information, it's robust to noise also. Okay, so let me show you a small demo in this regard, so as to prove my statement. Okay, and I have content. Again, I'm mounting my Google Drive in this Python notebook also. Okay, and what I'm trying to essentially try to do is I'm reading the cameraman image. Okay, also I'm reading a pepper's image. So this is the capsicum or the whatever. This is the other image other than the cameraman is there. It's a pepper's image. Okay, so I'm using this subplot. Okay, if you see here, in order to display both the images on a side by side, I'm using a function called subplot, and this is pretty much the same how it is done in MATLAB. In case if you have an experience in MATLAB, this is how pretty much same. See, there's lots and lots of similarities. When one of the main concern that I have encountered with the faculty and the students is, sir, I have an experience in MATLAB. Will it be really possible for me to venture into Python? Of course, yes. You'll be. See, Python is pretty much similar to MATLAB. Okay, yes, of course, Python has its own ability. Suppose say something like dictionary is not there in MATLAB. Okay, and you'll not be. There are some many more powerful features are there with Python. Okay, and it's also advantages. The way it is advantages is MATLAB is something like, for me, it's a commercialized software. I don't want to use something like commercialized, and that's the reason many of the industries these days are preferring to have Python code in Python only, because MATLAB is something like I have to pay for it. Officially, if I want to use it, it's to pay for it. Okay, so I would recommend every one of you to think about shifting to Python in case if you are not. Okay, it's pretty easy if you are comfortable with C programming and or MATLAB. Okay, you can easily shift to Python. Okay, I also used to have this concern, and one of the best ways, in case if somebody is interested to shift to Python, and then they want to learn more about it, just email me your interest. I can redirect to you some good course online which you can go through. I went through multiple courses, and I don't want you to go through that phase of identifying a good course and losing an interest of learning Python when you are in that fire, or when you have that passion inside you to learn that new language. Just identify a good source and get in touch with the experienced people and get the details of that course information and get it done, get learned about it. Okay, so this is coming back to this Python code. This part of Python code, if you see, this is a subplot which is pretty much similar to by MATLAB. Okay, MATLAB also has a similar subplot. So I am initially the first two parameters. It will determine how many images are there, and so what should be the arrangement of images, whether it is 2x2 arrangement or 1x2 arrangement. Okay, that is what it does. And here it's a 1x2 arrangement. That means I have a one row and two columns. So that is, so if I want to display this image two images horizontally, one side by the other, I will use 1, 2. And if I want to display one below the other, I'll use 2, 1. Okay, and the third parameter represents the index of the number. Okay, the first image will have an index of 1. Okay, and the second image will have an index of 2. Okay, I'm reading the images here. Okay, so in this portion of Python code, if you see, okay, what I'm trying to do here is I'm estimating the Fourier transform of my images. Okay, np.fft.fft2. It will use a fast Fourier transform approach in order to identify the Fourier transform. Hello,
sir. Karthik sir.
Yes.
This is Suresh sir. Sir, your screen is not shared, sir.
Okay. Up to from which point? Maybe it must have got disconnected.
Yes, sir. Disconnected, sir.
Okay. Just a second. I'm trying again. Is it coming?
Yes, sir. Coming, sir.
Right. So what is the last thing that you have seen on my screen?
Past cameraman and salt and pepper, sir.
Right. Good. Then we didn't lost, right? Just try to interrupt me in case if there is any disturbance now also. Okay.
Okay, sir.
Right. So now if you see here, I have something like I'm trying to estimate the Fourier transform of the first image. I'm getting I'm doing the inverse Fourier transform by using FFT. What do you say? FFT2 and IFFT2 functions within my NumPy package. Okay, so that's the reason. Any kind of an array processing, and it has a great support for doing image processing and computer vision tasks. The NumPy has a great support for it. Okay, and I'm trying to extract the magnitude transform and the phase transform. Okay, for the first image, I'm getting the magnitude transform and the phase transform. I'll do the FFT. Sorry, I should not call it as a transform. I'll extract the magnitude information and the phase information. In the similar way, what I try to do here is I'll try to extract the magnitude information as well as the phase information for the second image. It's the same thing that I'm trying to do over here as well. Okay, so what I'm trying to do in the subplots is I'm displaying my images now. Okay, I'm displaying my image, and the first one is the cameraman. This is the magnitude transform. Sorry, the magnitude part of the Fourier transform, and this is the phase part of the Fourier transform. Okay, and right, and this is the IFFT2. This is some color coding. I have to do a small rectification to this, but however, it should be looking as like this only. Okay, and now here, this is a Pepper's image. This is a magnitude transform. This is a phase, and this is the inverse Fourier transform. This also should look like this. There's a small correction that I have to do, but which I forgot to do. Okay. And now what I'm trying to do over here is, okay, right, once I have got the magnitude spectrum, phase spectrum, okay, what I'm trying to do is I'm using the magnitude spectrum of the first image and the phase spectrum of the second image. Okay, and the phase spectrum of the second image in order to construct the new Fourier transform over here. Okay, and I'm using the magnitude spectrum of the first image, and here if you see new IMG 1 underscore FFT, what it's trying to do here is I'm using the magnitude spectrum of the first image and the phase spectrum of the second image. In the second case, I'm using the magnitude spectrum of the second image and the phase spectrum of the first image. Okay, and it's something like a crisscross I'm doing over here. Okay, and I'm applying the inverse Fourier transform. Okay, and trying to reconstruct such a kind of a new image which is there. Okay, and I'm trying the plotting also now over here. Okay, so I'm plotting here. Okay, if you see here, okay, in the first case, here in this case, what I'm trying to do here is I'm taking the magnitude spectrum of the cameraman and I'm taking the phase spectrum of the Pepper's image. Okay, and that's how, and I'm trying to apply the inverse Fourier transform. So what does this particular image has? It has the majority of the information which I am seeing visually is because of this Pepper's image which is there. Okay, and what I am taking out of this Pepper's image in order to reconstruct this image, I am taking the phase information of Pepper's image. Okay, and let's try to do the other way also. I am taking the magnitude information from the Pepper's image and I am taking the phase information of the camera image. Okay, and I am reconstructing this. Okay, if you see here, this has majorly the cameraman, but the Pepper's information, maybe it might be there, but visually you are not actually you'll be able to see it. Okay, so the phase information is more important than a than a magnitude information from my Fourier transform. Okay, why I'm saying this? Even when you're transferring your information from one place to other, okay, you just by using the phase inverse of the phase transform, you can actually infer what is your actual image is all about. Okay, and that is the, and phase actually, all this is happening because phase has more robustness towards the noise. It is not easily degraded. It is not easily it will not be getting affected by using noise actually. Okay, it has much robustness. Okay, so coming back to my PPT. Okay, and right, so here if you see, there are the face recognition is some let me talk about some of the latest areas now. Okay, so that you'll get a feel about where the research is heading towards, and what are the different kinds of research problems that you can think of while doing your PhD or whatever it is. Okay, Suresh sir, is the screen visible?
Yes, sir. Visible, sir.
Okay, good. So detection of faces with mask, low light, and scattered light. So now that COVID-19 is there, okay, social distancing has to be maintained everywhere, in public places, in the shops, malls, and everything. Things are going to change. Okay, the new normal will not be any more like the old normal. Okay, and so all these surveillance data until now, okay, which were mainly used in order to monitor how the crowd movement is happening. Now they will start work towards having a technology to identify these things also, right? Identifying the faces with mask and identifying the faces without mask. And if somebody is going around without mask and is doing some kind of a mischievous activities, then authorities should be alerted appropriately. Okay, and I have sometimes what happens is during the nights the lighting conditions are not good. Then how will you identify the faces? Okay, and in presence of mask, can you actually detect or recognize the faces? Now, suppose say I am present in front of a camera and it recognizes, without the mask, it recognizes me as Karthik. Okay, and can the same face recognition system do the same job with a high accuracy, saying when I'm presenting itself, when I'm presenting myself in front of it, okay, can it do the same job when the mask is there? Is what is the biggest challenge these days. Okay, because the mask usage will become very extensive. Okay, and all your face recognition system should be able to adopt for identifying the faces with mask also. Okay, and scattered light, of course, something like when you are traveling on the hill stations and everything. Okay, there is a lot of smoke around during the winter, and you are trying to identify the faces in the presence of some kinds of fog or the mist and everything. That's what is about the scattered light. Okay, and the face recognition through surveillance videos. Of course, surveillance videos are always low resolution in nature, okay, because it's trying to record the data continuously, and it should be able to store the data also, and so that's the reason it tries to maintain the resolution at a very low. Okay, it will not surveillance videos will not have a high resolution. And when you are trying to understand the faces or the people around the scene from through the surveillance videos, it will be very, very difficult. Okay, because these low resolution images identifying the faces will be very, very difficult. Okay, so now what is a best way you can do? In many movies also, they show about pixelation, right? So it got pixelation, and then you need to depixelate it in order to do it. What effectively they are trying to do there is they're finding a way in order to improve the resolution of the images through softwares or through some advanced image processing techniques, so that they'll be able to identify the people in those surveillance videos. Okay, and another area which is just picking up is emotion recognition, right? So let me at this point, maybe let me tell you about one of the projects that we are effectively doing. So many a times, sometimes what happens is, due to the workload, the employees in corporate generally they get stressed out. Maybe the employees who are working in an organization can get stressed out. Okay, and now we are trying to build a system, okay, by uh, uh, what kind of activities, or in what way we can help that particular employee to come out of that stress. Okay, and one of my friend who was participating in the experiment, he had high blood pressure before starting the experiment, and his pulse reading was monitored, as well as his face was also observed. His face was observed through a webcam, trying to understand his emotions through the faces. Okay, that's where the image processing will definitely help try to analyzing the emotions by using the face images. Okay, and now everything is monitored, and then now he's given with reading task. Maybe he's asked to read some articles. They placed articles around that place, and then he's given several different tasks like reading, writing, and everything. And one of the tasks was puzzle. Okay, and then now puzzles, and then he was solving those puzzles over the period of time. And then once the experiment got finished after 15-20 minutes, and his blood pressure was measured again, and it was perfectly all right, 120/80. Okay, it has perfectly came to normal. That means for that particular person, what do you say, puzzle solving is something which can help you to cope up with stress. Okay, so somebody will be like music. Okay, my wife, whenever she is doing her research work, she ensures that she is also a PhD from IIT Madras, her specialization into materials chemistry. In fact, we both are co-founders of, along with me working, we both are co-founders of a company called Icarus Research. We just registered it a week back. Okay, and right, so we do various support programs with respect to research in that. Maybe one of the initiatives I'm going to present in the next slide. And so she likes to listen to music more whenever she's doing her research activities. She likes to listen to the music whenever she's in stress. Okay, or she one of the things she does is something like a comedy programs she would love to watch, so that that stress is not taking control of her. Okay, when she is in stress, sometimes what happens is majority of the ladies, they will have this problem of migraine. Okay, so so before even going to the stress, if you are doing some kind of an activity which can remove you from that stress, and we are trying to do research on that part, on identifying such a kind of an activity for a particular person, on which can remove stress. So when you are doing these kind of an experiments, identifying the emotions from the faces plays a very, very important role. And this is only one application that I've told you, and there are multiple applications which deals with emotion recognition, and that will help a lot. Okay, and face anti-spoofing, right? So this is another thing which I wanted to talk. Suppose say I have a biometric system in my biometric, which reads the faces. It recognizes the faces at the entrance of my company, and it tries to allows me in if my face is authentic. Okay, sometimes what happens is, just by showing my photo, I'm not physically present, but if somebody shows my photo, it still recognizes it. Some of the face recognition system does it. That means I'm spoofing my face recognition system just by using my picture rather than me being present there. Okay. In that way, what happens is anybody who has my ID card or a photo can enter into my company. Okay, there is no security in that case. Okay. Also, these days people are using 3D face masks. Okay. You have placed a 3D face mask on top of your face, and then now you present yourself in front of a face recognition system. It will identify you at that as the person which that 3D mask is depicting. Okay. Now these are the several different challenges. We call this as a spoofing technology for face recognition systems. Now, anti-spoofing is something where you build a technology which is robust to all these cases. Okay, whether just by showing a photo or a 3D mask, the face recognition system should not allow the person to enter inside. Okay, it should be robust in when it's trying to identify. So face anti-spoofing is something which is dealt very nicely. Okay, and if somebody is interested to work in this area, this is the data set what I've mentioned, the cross ethnicity face anti-spoofing data set. This is the data set which you can make use of in order to build your machine learning or the deep learning algorithms. Okay, and there are some other challenging areas. AI for content creation. Okay, nowadays after COVID-19, there are a lot of webinars that are happening. Okay, or the teaching is getting converted into online mode these days. Okay, after COVID-19, and earlier also it was there, but however now that has become a norm these days. Okay, so AI for content creation, can I use artificial intelligence in order to generate the content, the presentation content? Suppose say I'm presenting something, can I generate this PowerPoint presentation, whatever I'm using today, by using artificial intelligence? Is what one thing which people are seriously working on. So the content generation is based on artificial intelligence. Something like embodied AI is another area which people have been working on very recently. This area is all about understanding infants, how the kids of say of 2 years old to 1 year old or 6 months baby, how it will learn its task. Okay, it's trying to identify people around, it's trying to identify mother, father. Maybe through senses it will definitely able to identify, the baby will be able to identify, but as the time goes by, how it's trying to understand, okay, this is the people and what are the different kinds of an objects, how it's trying to learn, how the baby is trying to learn that kind of studies. Because if you are designing some new system, okay, which has some kind of an which has the ability to observe the environment and learn by itself the way humans behave. Okay, if you are trying to create such kind of a system, then embodied AI actually helps it better. Okay, and these are some of the challenging areas. So summarizing today's talk, the first talk was more on industrial perspective, different applications. Today I spoke about different things about Python programming, some of its features, on how you can use them in order to do your Python programming, and some of the latest research areas are also have covered, and also spoke about optical character recognition application in the Fourier transform. These are the different things I've spoken about. Okay, in 2 days, actually, it's quite difficult. Because earlier I used to do these 2 days programs, but somehow very recently I did a 5-day FDP program, and after doing that, I'm feeling that okay, 2 days is quite short time to convey the message properly. Okay, but I did my best in order to do it so that I have a balance of both programming as well. So I'm not just leaving at an industrial use cases, which you may see majority of the webinars do, but I'm just giving you an starting point on how you can get started with Python program. Okay, these are the different things I spoke. Okay, so as a part of our company which we have recently started, okay, there's an initiative that we have given. Okay, for this is only for serious people who are really interested to learn from us. Okay, on computer vision and image processing, we have designed and initiated a comprehensive course on computer vision and image processing, where it should be computer vision and image processing, not pattern recognition. Okay, and this will be like a 6 months course, mostly starting from August first week. and what we'll be typically covering is image processing and computer vision fundamentals, along with a balance of programming perspective. Because just by talking theory, I don't want to be another theory class. You know, the theory is there across the internet and multiple places. But I want to show you, when I'm teaching a certain concept, say image enhancement, I want to show you practically how image enhancement works, where all image enhancement is being used. Okay, so that is what it is. So I also introduced about in that course, we'll be talking in parallel. The subject we'll be talking as well as the Python programming also will be talking. So you'll be having a weekly quizzes, mini projects, paper presentations, and final project. Okay, and one additional thing that we are offering is on all the top 10 performers. So if you are one of the main requirement criteria that we are keeping here is we need to have at least 80% or more, okay, in terms of attendance, as well as the you need to have 80%, you have scored 80% or more by solving these weekly quizzes, mini projects, final project, everything. Then only we'll be offering the e-certificate under iCrest research. Okay, that's a e-certificate that will be offered. Then only that is being offered. Okay, and all those top performers who will be continuously monitoring everybody who is doing their task during the complete duration of the course, and the top 10 performers will be picked up. Okay, and they will be given a support of publishing a paper in they will be given enough guidance. See, we are not a company where we will be writing the research papers. Okay, that's absolutely unethical to do. Okay, we won't write your thesis, or we won't write your research papers. Okay, what we will do is, we will, out of our experience, we are going to guide you in publishing in the top conferences, and we'll be working closely together and help you to understand what are the different elements that you need to focus on in order to publish papers in national level conferences. So one of the best national level conference which is there in India today is National Conference on Computer Vision, Pattern Recognition, Image Processing and Graphics, okay, which is going to happen in 2021, and September 2021 will be the paper deadline. Okay, and so our plan is, for the first batch, we will finish the course by approximately January or February. From January or February, we'll be picking up a topic, maybe out of mutual interest. We'll be picking up a topic in computer vision and image processing, and we'll be working towards contributing something new and write a paper for this conference called NCVPRIPG. Okay, so only the guidance part will be given. The person or the candidate who is registering for the course, he himself will be writing it. Okay, no, only the support part will be giving it. Okay, because there are a lot of organizations whom I know, they will write the research papers on behalf of research scholars. Okay, they will buy the papers and because one of the way I did my BTech project, of course, maybe due to the lack of guidance or some reason or the other, I paid some money and bought the project. And when reviewer has seen my project, is almost like he made fun of me. I didn't like it. I felt like, okay, I should not do ever, and I should not encourage also others also to do the same. Okay, so we are only giving the guidance part, and the course completion certificate, who attends the complete course and secures more than 80% in terms of attendance as well as marks. Okay, so this is about the comprehensive course on computer vision and image processing that we are going to offer as our first initiatives here. Okay, and I will be the instructor for that course, and right, and there'll be few people whom I will be employing to manage with the course logistics and everything, for which of course there will be some financials involved in employing and doing that course logistics. So there will be a minimal fee which will be charged, because from my past experience, what I've seen is, if I'm offering something at a free of cost, it's not being valued at all. Okay, I've guided almost like maybe 50-60 students for GATE and everything, right, for preparing for GATE and everything, but only 3 of them have taken very seriously whatever time I've invested, and then they picked it up, and today they are at Microsoft and some startups in the manufacturing sector and everything. Only 3 of them has taken very seriously. So a minimal fee will be charged. Okay, we have not exactly decided the fee structure and everything, but a minimal fee monthly basis will be charged, so that suppose say in a particular month you are dropping out, okay, and you are not liking it. Of course, your money won't be getting refunded. That is one thing. Okay. The second thing is, once you have dropped the course, you are not allowed to rejoin until 2021 December. Okay, because we want to successfully execute the first batch, whatever whoever has registered, whoever seriously wanted to learn from us. Okay, we want to successfully help them in publishing papers. Okay, and equip them with all the skills necessary for them in order to be successful in this area. Okay, so that is about the comprehensive course. If you have more queries with regards to this course, maybe you can drop an email. Okay, and this is my email ID, and if you want to get connected with me on LinkedIn, I will be there as Dr. Karthik Simapurthy. Okay, and that is my full name. That is how I'm there on LinkedIn, and in case if you want to get connected with me on LinkedIn. And thank you very much for Rice College, Dr. Venugopal sir and Dr. Suresh Garu for really for giving me an opportunity to share my knowledge and perspective. And I think more than the first session, I really enjoyed the kind of interaction that I had today personally. And I'm sorry for the inconvenience that was caused yesterday, because that was out of my control and I could not do anything. Somehow, I hope I was able to give out the contents in a very much clear and crisp way today. Right, and thank you very much,
Thank you very much,
Rice
sir.
College, Dr. Venugopal sir, for giving me this opportunity. And a special thanks to Mr. Giridhar. Okay, he's
Yes,
been more enthusiastic to help people and connect industry experts through his organization. He's able to connect experts to industry experts to academia. I think he's doing a great job. A big thanks to him for connecting me to academia and helping the academia to get the perspective of what industry is been doing. And thank you very much, everyone.
thank you very much, sir, Karthik sir.
Yeah.
On behalf of Rice Krishna Sai Group of Institutions, I thank you very much, sir, for giving a wonderful sections.
Yeah, I'm open for questions if any participants have.
Yes, sir. From participant side, if you are having any doubts, you can please unmute your mic and you can ask. I have given the permission. Please unmute your mic and you can ask. I request from the participant side, if you are having any doubts, you please unmute your mic and you can ask.
About PCA. Okay.
So,
So, right, PCA is all about dimensionality reduction, as it is rightly being said. Okay, and why you need to reduce dimensions is another thing. I don't have that PPT today, but however, they was see. Let me tell you something where one of the project I have shown in the first session also about the industrial boilers. Okay, where the industrial boilers have a lot of coal that is getting burning and the fire is getting generated. And sometimes what happens is, if the settings of the industrial boilers are not optimum, then the coal will not get burnt efficiently. That is the scenario. Now what industrialists are doing is, they are installing the camera inside the furnace, okay, at high temperatures. So the camera is robust enough to withstand that heat. And then now the camera is capturing the flame that is getting generated out of the coal. Okay. And now out of this, what the client has given is, the client has not given us the videos of the coal directly. So the videos of the flame directly. What they did was, they gave us something called CH-lag features. Okay. CH stands for cubic higher order local autocorrelation features. These are the some of the prominent features that you can extract out of videos. Okay, so these features are of size, suppose say for 15-minute duration videos. So they extract this CH-lag features and give it to you. So the size of CH-lag features are like 27,000 rows, 27,000 rows approximately. Okay, and 279 columns. Okay, you can visualize the amount of features that will be coming through CH lag. Okay, but what we have realized is not all 279 features are useful to me. Okay, so what we try to do is we will use PCA in order to identify which among these 279 features are important. Okay, and then we will extract only what do you say, those features are important, and we will use only those features for further processing or building any kind of a machine learning model. Okay, so this is how PCA is being used to identify the important features in my data. Okay, so that I'm reducing 279 dimensions. Okay, 279 columns only to 6 columns. Okay, so that I'm trying to identify only the important information, and then I'm doing further processing. Okay, so the PCA essentially is used in this kind of a scenario. So you have multiple features. Okay, even in the mining example also, what we did was I have shown the mining example where the Pravina ma'am, did you see that video when I played in the last session?
Yes, sir. Yes, sir. Yes, sir. I have seen, sir.
Right.
Yeah.
There also,
Sir.
what we did was we extracted multiple features of flame. Okay, we extracted area,
Okay.
we extracted velocity, we extracted
Yes, sir.
frequency.
My doubt, sir. My doubt is 279 can be reduced into 6 features, na, sir. How we know, sir? Those features are irrelevant like that, sir. In that.
Correct.
The,
So that's an interesting question, because PCI is always associated with something called eigenvalues. Okay. So now when you're examining those eigenvalues, what happens is the eigenvalues corresponding to only those 6 features will have significant in number, will be significant in number. Rest of the eigenvalues corresponding to other features, they will be very close to 0. And that's how you'll be able to identify, saying that, okay, these 6 features are important to me.
Okay. Based on the eigenvalues and eigenvectors.
Right. Based on the eigenvalues and eigenvectors, you can really determine that. Okay. And in case if you have any further doubts, maybe through voice, I'll not be able to explain it properly, but we can connect on a personal basis and then try to understand how you can use dimensionality reduction for your own application. Okay. Maybe you just write a short email to me, and then we'll offline after this session. Maybe this week is little occupied, but next week we can connect sometime, and then we can discuss further on how you can use this in your research.
Okay. Thank you very much. Thank
Welcome.
you.
Yeah.
Thank you very much, sir.
Right. There were few chat box comments. Sir, can we say to our students to approach you if they want any guidance in their career? Absolutely. They are most free to welcome. Please give my email ID to them. I'll be able to help them.
So still from the participant side, if you are having any doubts, you can ask. So that's all I think so, sir, from the participant side.
Sure, sir. Sure.
Thank you very much, sir, for giving wonderful sections regarding computer vision and image processing. So on behalf of Rice Krishna Sai, I thank you very much, sir, for a good platform creation and sharing a very good knowledge to our participants and students, sir. So thank you, sir.
It's my pleasure, sir. I thoroughly enjoyed, and thanks for your management and everybody who made this webinar possible.
Thank you very much, sir.
You're welcome, sir.